Thanks for getting started. Talk to myself. It'll be a good time. Let's make a board game. What are the rules of our board game? So let's have. I want a card game. Well, obviously we need a board. Let's say it's a square grid. Make it easy on us. Couple of rules. Let's say there are players. There are. What's the theme? Let's make it spooky theme. Sport game, spooky, haunted house, escape. They're players. They're gonna be ghosts, and skeletons, and monsters. Monsters. A turn consists of each player rolls a die to pick a monster type to move and how many spaces to move that monster. Player can move that monster up to that many spaces. If a monster lands on a player, if a monster stops on a player, that player cannot move until the monster gets moved off them. They play a special card, right? You know, an escape card, something like that. All right, so player moves the monsters, then the player can either move one space, play a card, discard up to their whole hand, or pass. Gotta make passing an option. Cool. So let's lay out the cards. So cards, players can hold up to 4 cards. So I think 4 is good enough. 4 cards at one time. At the end of their turn. Hey John, how's it going? Can you hear me okay? They restart. Up to 4. Let's say there are move cards. There are escape cards. Away from it. It's already like 3 feet away. I don't think I can make this thing any louder. Whoa, get closer. How's that? Yeah, the microphone still needs a bit of positioning. 10 feet? Alright, we'll go down to 10. 20 might be a little too much. Escape a monster card. You're gonna have to get a mechanical keyboard so you can hear it more. Or a less sensitive microphone. Yeah. What are we doing? Cards. Alright, so we're going to move cards. Let's say move 2. Move on speed tile. So like maybe like it's not gonna be a road. I'm imagining this inside of a house, like a road. You can move faster on carpets. Or should escape a monster card. Move, escape a monster. And I don't know. I think that's good. Alright. I think we've got the good turn sequence in. So player rolls a die, move the monsters, and then players can move one space, play a card, discard, or pass. So things we're going to need for this is going to be a board. On a grid, we're going to need a player. We're going to need an enemy. Some sort of dice. And some sort of cards. Alright. Let's get hammering away on this thing. I also just realized I forgot to post this anywhere. C'est la vie. Alright, who can we bug? What communities am I in that I can post this to? Or do we just go for it, record it, see what it looks like later? Let's just get into it. Alright. So I've got a blank Unity project up. Almost blank. So this is just the default scene, or the default Unity project, with all the extra stuff taken out of it. Let's start with the board. So like, just a grid board. It's going to live inside of a game object. And I'm just going to call it board. Just have a script that is not what I wanted. Have a script that does all the board stuff. So this can manage, all of the spaces and then all the pieces that are on that board. And then we can ask the board to do things. So we can say, hey, board, move this player, to this space, or where can this player move, or highlight this player's potential moves. It sounds like a lot of work. So let's get an editor popped up somewhere. There it goes. All right. Oh, look at that. I already got stuff in here. All right. Board. Let's start with the simplest implementation we can. We're going to have a list of vector... Oh, come on, Ryder. Catch up. Vector 3 integers. And then we'll call these cells. Just have a list of all the cells that anything can exist on. Oh. Did my stream go out? Uh-oh. Let's see if I can tweak this a little bit. All right. All right. So I guess it's still going. YouTube's telling me we're not streaming anymore. But cells, we need a start. Let's populate those cells. A new list. Let's start with just, the simplest list we can. We're going to do just a 3x3. We can move around, do some stuff. And so I'm just doing an implicit list. I forget what these are called. Throw some commas in. So I've got stream beats going. So Stream Beats is designed for YouTube. It's, you know, royalty free, whatever stuff that anyone can use, which is pretty cool. I forget who pointed me to it. Let's put some cells in. So I've got XYZ. Unity is obviously a Y up, Z forward. So we're gonna go X 1 1 1 or 1 2. Right, so we're just gonna have a simple grid. Not what I wanted. 1, and then we're gonna do 2, and those are zeros, and then this guy is going to be 0 1 2, and then 0 up is gonna be 1 1 1 2 2 2. Alright, so this should give us a grid of just 3 by 3, throwing in some coordinates. Let's get some boxes going. Let's see if we can visualize this guy. We're compiling. It's going to be happening a lot. Alright, I want to create a 3D. Actually, I'm going to create an empty. You know, something that can represent our cell in the scene, and then for now, it's just going to be a cube. We're going to drop this guy down half so that it sits so where the origin is right at the surface, and we can put stuff at the origin. So like, let's say we create our player as a sphere, right? And we drop our player. That's a bad example. We're gonna have to create this anyways. All right, our player. Let's say our player is a sphere, right? We're gonna want to start this halfway up, and then if we snap our player, right? So our player is gonna move around. If we snap our player to a cell, that origin point will line up with the cell's origin, even though the graphics are a child, and off she goes. Let's make a prefab out of this. Let's stay nice and organized. Folder, prefabs. Grab a cell, get this out of the scene. Go back into our board. Look, we've already got our list available. Public game object cell prefab, right? And then once we start, let's iterate our cells list and create an instance for each. Ooh, that's not what I wanted. I wanted a link for each. For each cell. This is not the right one. It is not. Alright, do it the hard way. For each cells in cell. Don't need you. Clean up some of that stuff. There we go. Our current cell, let's instantiate a cell prefab. And then we can give it, I always forget the order of these, the position, no, the parent position we want, not this guy, position, rotation, parent. So the position is just going to be the cell, right? Because that's a vector 3 int, it'll convert to a vector 3. We want the identity and then this as the parent. Why are you yelling at me? Can it resolve int? Oh, does it not like? Cell.x, cell.y, cell.z. Still doesn't like it. Can it resolve game object vector 3 quaternion board? Oh, this dot transform, right? Because you have to parent it to a transform. I wonder if we can get away without this then. Cell, neat. All right, save. Let's go run it. Where'd you go, Unity? Compile. Do some more compiling. There we go. Oh, we forgot to set up our prefab. Here's the board. Go into prefabs. Cell prefab. All right, do some more compiling. Still compiling. There we go. And we can see our 3x3 grid. All right, and then we've got the default camera mover script in here. So we've got a 3x3 grid. They're all objects, right, inside the scene. We can like snap our player to one. It's good times. What's next? Got a nice grid. Do we want to set up the camera? No, let's see if we can get the player moving around. So we need to connect the player and the board. I don't want to like set a hard dependency on them, so I'm gonna do a game manager here. And then game manager. Oh, let's just call it game. It's a good name. Good name for a script. Game. All right. Scripty boys. All right. So our game is going to need to know about our board. Board, and it's going to need to know our player. And right now our player is a game object. We don't need these guys quite yet. Excuse me. What is our game gonna do? So we need to set up the board. We need to position stuff, the player, and then start the first turn. And then we can go from there. So how do we set up the board? Board kind of sets itself up right now, which, there's two start methods, right? So we don't know when these are going to run. So let's make the board not instantly start up or set itself up. We'll have it, build itself. So how about we build the board? Oop. Build, right? So then we can call this and say, build the board. And then once that returns, we'll know the board is built and we can move forward. Let's also stick a method on here. I'm just getting a little ahead of myself, but get a start position. And then eventually we'll pass in like what player's start position or like, enemy items, whatever will go in there. But for now, it'll just be the start position since we only have a player. And that's going to be, smashing my keyboard all over the place. And that's going to be the 000, right? So we need to know this cell's world coordinate because that's where we want to start the player. So we can say something like cells and then figure this one out like 0, 1, 2, 3, 4, 5, 6, right? We can just say cells 6, simplest thing. But that's going to give us the 000. And it just so happens that 000, this gets instantiated, that coordinate. Eventually we're going to need to say like, cell coordinate to world coordinate. But for now, this works. And then we're going to have to figure out, what defines the start position. So we can say board build. Did I call it build? What did I call it? I already forgot. Oh, and it's private. That's why I said it's public. Board.build. All right. So once this returns, we know the board's set up. So now we can say player.transform.position equals board get start position. And that should slap the player right on whatever start position the board tells us is the start position. Let's give her a run. After we compile. Doing all the compiling tonight. And we didn't set up our script. That's all right. We'll just wait for more compiling. Give us a null reference exception. All right, game manager gets a reference to the board, gets a reference to the player. Let's go. And there we go. So it doesn't look like it really moved, but let's say we stick this guy way off in the distance. Do an application reload. There we go. Bam, right on that first cell. Let's clean up these cells just a little bit so they actually look like cells instead of just, you know, random gray boxes. So I'm just going to add another cube in here. Let's get rid of the box collider. Remove component. Let's change its color. That's just a default. Oh. StreamBeats has ads in it. Material, cell center. And come on. I don't know why this takes so long to create like random objects in your hierarchy. It is weird. There we go. Yep, center can be that. We'll just make it super smooth, or not smooth. We're going to change the color of this cube, shrink her down 10%, and just shove it right in there. Save, back up, run, reload it. There we go. So now you can see we've got a nice little grid that we can mess with. What's next? Let's get the player. So the player's on the board. There's a board. Let's move the player around. Yeah. So we're going to move the player. Start the first turn. So first turn is going to be the player picks an enemy. I don't really have enemies yet. What if we just... Do we skip that, or do we set that up right away? Let's set that up. Why not? First turn. So the first turn consists of pick an enemy and cells to move it. Let's say the enemy gets to move one for now. One space for now, and then player moves. All right. So this is designed to be multiple people, right? We can replace picking an enemy to move it with an AI, or, you know, multiple AIs that are players, so on and so forth. So let's add an enemy. Get a little reload in here. Should we switch from... The player's a sphere right now. What should our enemy be? Enemy. Should we make him a little, like a dude? Or do we import something real quick? Let's make him a little dude. Alright. Remove. Go reset this. Get our player out of the way. Oop, there we go. Move this up 0.5. Let's go 2.5. This is going to be half. We're going to make him like a little, what you call it, peg guy. Make him a little bigger. Maybe this will be like a, I don't know, skeleton eventually. And then she could just give him a tiny head. Oop, missed one. 0.1. that's a little too tiny. Yeah. This should be the player, right? All right. So we've got an enemy we can move around. Let's prefab these guys. Slap a prefab for an enemy. Let's slap the player down as a prefab. Let's get our board, or our game, instantiating these guys, just to make things a little more convenient for us. Game object, enemy, and then get these in here. After it compiles 20 minutes. Prefabs. Slap these enemy. Did I not make it public? That is the board, not the game manager. Enemy. Let's get the player prefab in there instead of the player. Then we can do this, and then some of this. And then we just gotta go back in here. Let's move this out. Set up player. And we're going to rename this to the player prefab. That's great. And we're going to rename this guy to enemy prefab. No spaces. Lowercase e. Good times. We're going to have to reset that back up. Then we'll set this as a private game object. Oops. And just call it player, private, game object, enemy, right? And these will be the instances. So let's say player equals instantiate, player prefab, and then we need what? Position, let's say board dot start position. No parents. Oop. Oh no, that's quaternion identity. And then I'm missing a transform. No, this guy's null, right? So we don't pass that one because we don't want him to be parented to anything. Or we can parent him to the board. Figure that one out later. So that sets up the player at the start position, and then let's add that in here. Set up player, right? We don't need this guy. And we'll do the same thing for the enemy. Void set up enemy, and then we'll say enemy equals instantiate enemy prefab board. Let's say get open position. We'll just have it return a random open position. Quaternion identity. Damn, why is this one lowercase and that one's uppercase? So on the board, let's create that method. And we can do return cells random range from let's just do 0 to 8, right? We've got 9. So that could return this one. How do we get it to not? Could they start in the same position? Let's just say they can start in the same position. Make our lives a little bit easier. Fix it later. Let's go back to Unity, reload. Give her a test. Alright. Nothing. Bob Kiss. Unassigned. Oh, yep. What didn't we assign? Our prefabs didn't get saved because I renamed them, and renaming stuff breaks references because everything in Unity is a text file pretty much. There we go. We've got our player, and we didn't call the setup enemy. Rider. Game. So we set up our player. set up the enemy. Start the first turn. Give her a test again, you know, make sure everything's working. Click the button. Ooh, I think I saw it. Gotta reload. There we go. So we've got our player and our enemy. Neat. Let's get the camera going. So I'm imagining sort of isometric. This is very, you know, off left field. Changed my mind. I'm imagining like an isometric view. So let's do something like get an empty in there. And just, I'm going to reset this guy. This is just for reference. Negative 0.5. So this is like the board, right? And we want to set our camera up. So let's stick this guy back at the origin. Let's clear his rotations. Let's switch him to local rotation. So isometric would be 45 down on the X, right? Let's go a little high. Let's go down 60. And then Y, it should rotate around the Y. But we want it to rotate around what the camera's pointing at. So let's create like a dolly. I do this many times. Do a cam dolly. All right. We're going to reset this guy to the origin. Reset. Drop the camera on there. And now I can do the local transforms and just back the camera up. Did I turn this the wrong way? 60? Yeah, I did. That should be positive 60. Now I can just, along the z-axis, which is the forward, slide this guy back until I get what looks like a good... Yeah, I can live with that. And then that does this positioning for us, because who wants to calculate, you know, that? When they said you'd never use trigonometry, there we go. Never use trigonometry. And then we have this dolly, right? So the dolly keeps an offset for the camera. And then with the dolly, we can rotate the Y around and it maintains that isometric-ish view. And we can move the cam dolly around on the surface, right? So let's say we want to point it at a certain cell. Then we can just set the cam dolly's transform to that cell and it will automatically align to point at it. Even if we have some like weird rotation, it's always going to point at that. So it's just like a focus. So let's get this guy moving. Camera mover? Switcher? Camera mover. That makes sense. Well, I gotta get rid of the old camera mover too. The default scene has like a simple camera mover. We're gonna delete that. In here, simple camera controller, remove component. Goodbye. So now we can open up our camera mover. Don't need you. Don't need you. And let's do something super simple. Let's do if input. Get key down, and we'll do the Q key. Key Q. Come on. And this is just, you know, temporary. And that'll rotate one way. Input, get key down, key code. I think you know where I'm going with this. E. We'll rotate the other way. And we can do transform dot rotate around. And this is point, axis, angle. So the point is going to be the position. Axis is going to be up, right? Up. And the angle is going to be however fast we want to rotate it. So if we want to rotate, you know, 1 degree per second, right? We can do time.delta time, right? Let's see what it looked at. You know, let's see how it goes. Copy this guy, plop that guy down there, and then this is going to be the same thing, just go the other way. Or you can flip, you know, the vector, make this down, you know, good times. Plop this in here again. I think most of the time is spent watching progress bars. All right. Q, E, no. Is it imperceptibly slow? No, something's up. What's on here? Oh, you know, it is doing it. See, check it out. Just barely moving. So, you know what I did? It is, where'd this go? Not get key down, it's just get key. So get key down only happens on the frame that it goes down, and then get key returns if it is held, if it's held down. Every frame it'll return true, otherwise false if it's not held down. Let's give this another go. If this will compile. There we go. Come on. Oh, it's going. Just super duper slow. Alright. Let's get rid of this guy. Let's go into our camera. We'll say public, float, rotate speed, and then time at delta time times rotate speed. And so if we do this, oops, rotate speed, and now we can adjust it on the fly. Find a nice number if it ever compiles. Come on, there we go. Alrighty, so let's start this at 10 degrees per second. I think it's in degrees. I don't think it's radians. Should be degrees. So 10 degrees per second. Yeah, that's pretty slow. Let's double it. 20. Nope, a little faster. 40. 80. That's close. I think going faster. Let's do the old double it again. 160. Oh, let's go 180. Let's do the full 180 in a second. Boom. Yeah. I can dig that. And then we can look around the board, you know, select where we wanna move. That's nice. Alright. So 180. So because we're in play mode, we've got to reset that guy. Perfect. Let's have the camera also track a target. So let's also do transform dot position equals target dot position. Oh, because I didn't. All right, come on. Transform target equals target dot position. There we go. So now if we get it to target, we'll just follow around the target. We can lerp this, you know, whatever. Simple, stay simple. Then we'll figure it out later. We need to set this as well. So let's save ourselves a little. Let's just set it up. Board. We need a reference to our camera. So we want the game, not the board. I want the game to be able to mess with the camera. So public cam mover, camera mover. In the setup, let's say camera mover dot target. That's not target equals. It's called player dot transform. Bam. Gotta go in here. Come on. There we go. Alright, so now we have our game manager. We need to give it a reference to our cam dolly. Fire her up. And test. Alright, so see we're rotating around our player. And now if we move our player around, you know, it's gonna like jump to different tiles, but we can still rotate around and look at our player. And then we can reassign that target as needed if, like, let's say you want to focus on the enemy you're moving. Excuse me. All right. Camera moving, camera targeted. Let's move the player. Let's move an enemy. So the first thing is moves an enemy. Roll a dice to pick a monster, move that many spaces. That sounds fun. Right. game. So we only have one enemy right now. Gonna pick that enemy to move it. So first turn, let's say var enemy, and we're gonna move him one step, right? Let's just create a method to do it. Move enemy. Right click, create method, void, perfect. So this is where we're going to start like interacting, right? So we know what enemy we're going to be moving, and we need to know where we can move them. So we need to start adding some information to those. That's a lot of moving parts that are about to come together. This is draw the rest of the owl. So let's say we want to pick a square, right? So we've picked the enemy, the only one in existence. We've picked how far he's going to go, 1 unit. Now let's pick a square that he can move to. So we want to do something like board, get moves, and then we're going to say enemy dot transform, to give it the position, and then we're going to say how far he can move. We're just going to say 1. Yeah, let's start with a simpler case. Everybody only moves 1. So let's create enemy get moves. And this is going to return a list of vector 3 integers, right? It's going to return a list of coordinates. And it's going to take like a starting position, right? Because it's not really the enemy that we're finding the moves. It's just... it's anything that needs the moves. So we can say if everything moves 1, we need options is a new list of vector 3 ints, right? And then we're just going to return that list. All right, so right out the gate, we're just assuming there's no moves, you can't move, can't do anything. And now we need to figure out where the enemy's coordinates are, not the world position, but we want the coordinates. And right now those two are the same thing. Should we just keep our lives simple and keep them the same? Yeah, that sounds reasonable. All right. But we need to convert the vector 3 into a vector 3 integer. I think there is a way to easily convert that. How about we do enemy dot transform dot position dot to vector 3 to convert to? No, that's not what I want. What if we just cast it? That sounds dangerous enough to work. Vector 3 int. No, there's a way to do this. Let's do some Googling. Convert vector 3 to vector 3 int. We could do it like piecewise, right? We could just say, convert the x to an integer, the y to an integer, the z to an integer. But seal to int or floor to int. Let's floor to int. That sounds fun. Vector 3 position dot floor. Oh, it's a method it's a static method on vector 3. Floor to int. There we go. So this is taking a vector 3, which contains floats, and flooring each of those floats and returning a vector 3 int representing that vector 3. Perfect. So options. All right. So now we've got the move options, right? Suppose we're going to assume that works. Let's highlight the board. Let's highlight cells so that we can say, these are your options, pick one. Gotta let the user know. So we can say board, what do we call this? Highlight moves? Yeah, that could work. And just pass it the list. Options. All right, so then this will go through, do nothing, takes vector 3 and options. This is going to go through and highlight. So we're gonna light these up. So here's another complexity spike. Right now these cells are just in the world, right? They're just in the hierarchy. Let's create a data structure to hold onto their coordinates and then some interesting things about them, right? So we're gonna want to have a class. Well, I think we just call it cell, right? Do we have a class called cell? Yeah, let's just call it cell. Public class cell. What does the cell contain? And this is just a regular C object. The cell is going to contain a vector3 int as the chords. We could do a regular vector3 for its position in the world, but I think that's going to be implicit to the game object. So like this cell will just hold on to that. So we need that game object. Can't use object. That's a reserved word. We're going to use ob. Yeah, I think this will be good. And then we'll have another. Should we have another one? Yeah, let's do this the other way. This is gonna be on the object. So each cell is gonna be on an object, and then we're gonna hold on to a list of those classes, those objects. So we can say public renderer, because we want to highlight it, right? Material. Do render, mesh renderer. So this is the one that we're going to highlight to a color, base, not base, color, normal, and then public color highlight. Yeah, that sounds good. And then we can put a method on this that's public void set highlight. And then another one that is public void set normal. Right? And these will do those things. So we can say renderer dot material dot color equals normal, and renderer dot, if I could type, material dot color equals highlight. Right. So now when we set up the board, we can create these classes, or we can put these classes on the prefab and then just grab those out. So the cell prefab, one of the cool things we can do is we take a cell, like this is a script, right? But let's move this guy out to its own. Oops, not abstract. Move to cell. There we go. Put them on its own object. We can go into our prefabs and grab our cell prefab, and on the root I can add that script. It's not a mono behavior, it needs to be a mono behavior. I'm going to make this guy a mono behavior so that it can be a component on an object, and then we can reference in each of our prefabs a cell. And this can just be smart. It can do work on the cell itself, you know, on a specific cell. Let's make it green. Nice green color. And then the renderer, we'll grab the renderer off this guy because we want to highlight that interior, right? And then the chord will set dynamically. So those are updated. Let's go into our board. There it is. Cell prefab got lost because we changed it. Put that in the cell. Go back to our scripts. Board. All right, so now when we instantiate one of these, we're getting a game object, but we instantly get a reference to that cell. And then we can say cursel dot coordinates equals cell. Right, so this is a vector3 integer that we're getting from this list, right? And then we want to save it back into it. Yeah. All right. So we have two structures now. We have the numbers of the cells and like where they go, and then we have the instances that we need to keep track of. So let's create a list of cells. We can't call it cells. Let's call this one cells and rename... Name that something. We're going to rename this one to positions. Right. And then this is going to be static. Not static, but this is going to be defaulted words of things. There we go. So now this will build all of these cells based on these positions. Let's rename this to be something better. Position, right? So the coordinate is the position, and then we are going to add, need to instantiate that guy in start. So this is something that can happen at any time, really. Let's do it in the build. The build is kind of the start. So we need this to be called cells. Whoops. Cells. Cells equals new list of cells. And we can pre-populate this by saying, like, you know, positions.length or count. So that'll automatically give us that space to put those in. And then we can do cells.add cell. So now, where were we? Let's highlight moves. So we need to highlight these options. And these are represented by vector 3s. So let's just iterate over our cells for each. C, come on. C dot set highlight, right? So this is going to grab cells where the cell C dot chord is equal to options, right? Where now this is a contains. We're intersecting two lists. So let's do it all in one. So if C dot, so if options contains the current one we're looking at chord, then we need to do an if. Oh my god, this is like blowing up on me. Let's just do a traditional for each. Link is fun. Come on. For each. All right. Opt. All right. We want to do it the other way, in cells. So we're going to iterate over our list of cells. Come on. So if options contains any, we want any. I'm going to throw a link in there anyway. Option dot, O equals cell dot chord. So if the cell's coordinates are in the options, then we're going to highlight it. Then cell dot highlight. Set highlight. Else we're going to set the normal, right? Make it a normie. Set normal. Bam. All right, so this is going to iterate over all the cells, and only the ones that are in the options are going to get highlighted, and the ones that aren't are going to get set back to normal. So like that kind of cleans up if like last call frame, what have you, that something was already set. So it resets all of them back to normal except for the ones we want to highlight. Whew. Let's see if this works. Come on, progress bar. There we go. All right, check our board. It's got our cell prefab, positions, defaulted, game manager, has the player, has the enemy, has the camera, has no target, but that's fine. Starter up. I don't think we called anything. So nothing's highlighted. That's fine, but it compiles. That's the important part. Game. Move the enemy. All right, board. Highlight moves. Oh, we did call highlight moves. Oh, haha. We didn't put anything in get moves. All right. So we want to go Manhattan moves, orthogonal moves, just forward, back, or left and right. So we're going to say if cells any where no, let's do contains. If cells contains, because cells is right, that's gonna be hard. Let's make this easier to look up. We're having a lookup problem. We have to look up to see if, like, let's say like the up position is gonna be chords plus vector 3 int forward, right? So like the z forward is going to be up. Let's call it forward position, just for, you know, keep everything lined up. And we have to check if cells has a cell with this forward position coordinate. So the easiest way to do that is a dictionary. So, and because we're probably going to be looking up cells by coordinate a lot, we should probably just convert this list into a dictionary. So let's do that. Let's call it a dictionary of, and then we're going to do vector 3 int, and each vector 3 int is going to represent a cell. And we're not going to have to do too much to fix this. Whoa, press some buttons. Dictionary, vector 3 int, delete you guys, boom, boom, boom. Cells that add cursor, and this is going to be position is its key, and then the cell is the value, right? So we can get the cell value. I think it might simplify this guy too. Cells dot values. There we go. So we just get the values. We don't care about like what their key is. We're just going to look them all up anyway. Just iterate over them. So we're nesting that list inside of a dictionary. So now we can say if cells contains key, and then just forward position, right? This is so if this exists, if there is a cell there, then let's just add it to our options. Okay, and we can do this for forwards, left, right, and backwards. And yeah, just repeating code, but that is okay right now. Forward, back, C. We need this guy. And then later we can come back and, you know, iterate over this and make it not duplicated code. Left position and then right. Right position. Right position. Right position. Right position. Great. So now we're checking the four cardinal directions. That's it. Forward, backwards, left, right. And if that cell exists based off of whatever coordinates we pass in, we're just going to add them to our options list and then return that options list. So this should work. Hopefully, maybe, unless it explodes. Let's take a look at our board. We messed with this. All right. Looks good. Looks good. Let's run it. Yay! So check it out. So now our enemy options. So he's standing here, and then we check the 4 directions. We added 3. Let's see what that's Z. Z's this way. So we check the up or forward, right, back, left, and then highlighted those possible ones. So now we need to figure out a way for the user to be able to interact with us. Be like, oh, I want to click on this guy, or I want this one. You know, this is the guy that's moving. This is the guy that's not. So now we need to do some fancy camera work. how do we want to do this? So the game is going to be highlighting the moves. And we need to click on a move and let, the game know where to move. So we're going to have a couple scripts talk to each other, or should we throw another script and like ask it to do stuff? Yeah, this is another little complexity spike, right? So you can do something like converting a screen coordinate to a ray, and then that ray can hit something. So we can do a little setup before that. Our prefabs, our cells, right? We're going to use physics for this. Ooh, physics. We're going to go to our cell, and we're going to look at... All right, this guy has a collider on it. I'm actually going to remove that collider. And I'm going to put the collider on the parent, because we don't want we want to separate the graphics from everything else. Center, -0.5. Right, we just know it's a square, right? Just so we can hit it. And then I'm going to put these on layers, right? I'm just going to stick them on a cell layer, just so we can filter, find all the cells, you know, shoot rays at them, pew 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 pew. And then let's do, Reiner. In our game, we're going to be, let's set a flag. Yeah, flags are good, right? Booleans. Use all the Booleans you can. They never hurt you. Let's call it selecting selecting coordinate. Yeah, that sounds good. Let's start at false. So now we can say selecting coordinate equals true, right? We're in this mode, this state. And so every frame we can check. We can do a ray. We can shoot a ray out of the screen, into the screen, out of the screen, and say, hit that cell. And we need to do a array. Var mouse ray equals I think it's input, or is it physics? Input. No, it's camera. Camera dot main dot screen point to ray, and then we do input mouse position, right? So this takes the mouse position, shoots a ray out of the camera, and we can look at, like, you can see once this compiles. Yay. The view frustum on the camera, right? If I can get close to it, there it is. The view frustum, you can see there's a square here, there's a plane, and it's gonna, the mouse essentially lives on that plane, and then you can shoot a ray out of that plane and hit the back one, and it just draws a line between the two. And we can use that to hit things in the scene. So I'm gonna do actually, instead of updating, if we are in selecting coordinate, let's select a coordinate, right? Let's do something special when we're in this mode. And then we can do if physics raycast. No, I want the specific raycast. Is it raycast all? Maybe I'm raycast. No, it's just raycast. And then we want ray out distance mask. So we're going to use our mouse ray. I hit caps lock. Mouse ray. And then we're going to say our distance is, let's go 500. We can tune that later. We're going to do a layer mask, so we want a cell mask. Right? We'll create that in a second. And then that's it. That looks good. Give that a body. Create this cell mask. Let's create it here. It's not an integer. I called it mask. Cell mask. Whoop. Mask. Clean up. We'll just put it up here. Public layer mask. Cell mask. 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 Got it. First try. Oh, we need our out variable. That's right. So this will just tell us if we're hitting something, right? So we can do debug log. Ooh. Hit a cell, yay! Right. And I'll do this every frame where our selecting is true, right? But because we do this, right out the gate, it's always going to be true. So we're always going to be selecting something. Let's see if it works. Go back into our game manager. So now I've got the cell mask, and I can just select cell, right? So now the rays will only hit those cells and not hit any other physics objects. Get another loading screen. Let's grab our console. Go over here. Are we doing it? No. Let's make sure we set cell. Nope, we didn't set the layer. Just this object. Save. Go back. Hit play. Try it again. Keep moving forward. Mess up. Go backwards. All right. Whoop. Yeah, we hit a cell. So now we're hitting a cell, and we can get info about that cell. And because that cell has a script on it, we can do stuff to it. All right. So we need a different. We need the out hit array info distance layer. Okay, so out hit info is the second one. Out var hit infos extra comma, and we can say hit a cell. Let's make this interpolated string, and then we're just going to throw the cell's name in here. So hit info dot collider dot game object dot name, right? And let's really quick go into our board, and we're going to name our cells real quick. So we can say per cell dot name equals another cell. We'll do what are we? Position x colon position z. And we don't care about the y coordinate because our board is flat. Jump back into Unity. Let's see if we can load this stuff up. Boop, run it. Hopefully it won't explode. So now you can see we've got our cells have like nice names in the hierarchy. That's what that name attribute is. And then we can go over here and whoop, I'm hitting a cell, and you can see it's changing as I move across the different cells. And that's grabbing the actual cell's object. So we can do we can get this script and figure out what its game coordinates are versus its world coordinates. Game. Alright, we don't need this guy anymore. So we can do var cell info equals hit info collider. Ooh, not the barycentric coordinates. Collider dot game object dot get component. We know it's going to be a cell. And so we can say like cell info dot highlights set highlight. Ooh. Nope. Set highlight, right? So this allows us to act on it, right? Because we wrote that little script. Let's see if that works. Give her a little play. Boop, up. And now we can highlight them. Great. Not very useful at this point, but we can highlight. But we know which one we're hitting. So we need to be able to get this cell info, right? We need to get the cell info coordinate, and tell someone about it, right? We need to be able to tell, this guy, because if the enemy, we're picking an enemy, we're moving at a distance, we need to tell it what move. So let's set up an action. And we're going to set the action of vector3 int. Selected cell. Right? And then here, this is probably not a very good architecture, but But you know, it's what we got. We're going to say selected cell plus equals cell chord, right? Enemy dot transform dot position equals cell chord. Bam. So we're subscribing this method, this lambda function, to this selected cell. And then also, it's always going to do it. So let's do something like private void move enemy, and then we can just pass it the coordinate. Because right now we're assuming one enemy, just move him. We're not gonna do anything special with him. And we can do enemy transform position coord. Oop. God, cannot type. Going too fast. Cood? Cool. Oh, that's why. Chord. COORD. Nailed it. Right, and then we can unsubscribe. Select cell minus equals move enemy. Cell. Right, so we want to pass it up. Cell. Whoopsie. Minus equals. Move enemy. Oh, hang on a second. Has 0 parameters. Move enemy. Oh. Do move enemy. Naming things is hard. And then do move enemy cell chord. Whew. All right, and then we can do since we moved him, selecting chord, false. And then here we can say selected cell question mark dot invoke with our cell info dot chord. So this this question mark is a null coalesce, and if nobody has subscribed to selected cell yet and it's null, it won't explode, it won't null point, it'll just skip the line. But if there is someone there, it'll invoke this method with this parameter. Good times. See if it runs. Progress bars. All right. Oh, it did it. Ah, see how he moved? Let's try it again. That's up. All right, so he's in the, what coordinate is that? He is in the 1, 0 coordinate, and if I go over here and boop, now he's over there. And I unsubscribed, so like I can't select anything now. Great. Now let's make it so that we have to click on it. So we're selecting a chord, mouse ray, if input dot mouse button, get mouse button up, down and up, yep. Make it a left click. And we'll only do this if we are ray casting. So if we're ray casting and we're on it, there we go. So now if we click, it will grab the info. So if we're on a cell and we let the mouse button up, we'll do the click or do the move. And come on. I can't believe Stream Beats has ads in it. That's fun. All right, so now I can mouse over all I want, and then once I click, boom, there he goes. And then I can't click anymore because I'm no longer selecting. Next thing is, so we can only click on available moves. So if we get a hit info and we mouse button up and the cell is in the available list, so we can do something like let's cheat a little bit. If cell info dot render dot color render dot material dot color is equal to the cell info dot highlight. So if it's highlighted, then we will select it. All right. So now we can't click on anything that's not highlighted. This is kind of a bad idea because it's reliant on this renderer material. But we can change this to like some sort of flag that's not dependent on this material color. But let's see if it works. Progress bars, run it. More progress bars. There we go. All right, so I can mouse it around, I can look, and click, 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 not happening, and then click, and he moves. Right, we're all done moving. So let's do a couple more things, and maybe a little quality of life stuff. Let's do something on board. Let's be able to clear the board's highlights, right? So we want to do essentially this to everything. So we can do public void clear highlights. This will just clear everything. Cells, cell. So we can just say cell.value dot set normal. All right, and this will just go over the whole thing. And that will clean this up, right? So we don't need to do this twice. We can just, we're going to iterate twice. But if we want to clear the highlights some other way, clear highlights, right? We're just going to clear all the highlights and then run over these and set the highlights. So this means we're going to iterate every single cell. What if we only iterate the options? So now we can say for cell in options, if cells dot value cells dot keys dot any cell, then it is not the option one, it is this one. So we do cells cell, because that's the key now, dot set highlight. Right, so now we're only iterating the options list instead of every single cell, but we are iterating every single cell and setting it to normal. But this seems a little bit cleaner. And in here, let's say once we finish selecting, right, we do a move. Once we're done selecting, we can do board dot clear highlights. Boop. Come on, Unity. All right, let's give this a try. All right, rotate. Click, 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 not working. Click, move. Now we can move on with our day. Awesome. And we should be able to extend this to the player pretty easily by just doing move player. Create this method. Just a void method, and it's gonna look very similar to the move enemy. Let's move this guy down here. So we're gonna do the same thing. again, copying and pasting code. We're going to highlight the moves, but instead of enemy, we're going to do player. Highlight the moves. We're going to say selecting chord true, right? So we can, come on, true. So we can select, and selected cell. We're going to add, and we're going to say cell chord. And do move player, cell chord. Add this guy. This is a void, vector 3. So this is going to be nearly identical. I think it actually is going to be identical. We can refactor this later. I'm going to say player, transform, cell chord, selected, remove, do move player. All right, we got to unsubscribe the correct. Clear, selecting false. All right. Let's give it a try. So we should move the enemy, then move the player. Did we load? All right. So, we got all the way to player first. Click, move the player. Yep. We didn't sequence something right. Oh, okay. So we're gonna move the enemy, right? And we're gonna go through move enemy, and it's just gonna set the selecting, right? And then just instantly go into moving the player, right? We need to sequence this a little bit better. So we need to set up our state machine so that we wait until we move the enemy, then we move the player. How are we gonna do that? Let's about an hour and a half. I think we've got a lot of work done. Let's save that for next week. So I'm gonna try and do this once a week. Just make a little progress every week, and let me know what you think. Thanks for hanging out.